Hi students, this is Mr. Yao. In this lesson, we are going to continue our learning with trig, and today's lesson is about inverse trig functions. When solving equations, you use the inverse operation to find the value of the variable. So for example, when you have say 2x equals 3, you're going to divide by 2 to be able to find x is 3/2. So that's inverse operation. In trigonometry, you can actually find the measure of the angle by using the inverse of sine, cosine, and tangent. So in previous lessons, we have been writing things like sine theta equals 3/5, for example. But what exactly is that theta? Like what angle is going to give you 3/5? So in this lesson, using inverse trig function, you're going to be able to find out what is that angle. And typically, we read the inverse of trig function as arc. As for why it's called arc, later in the unit, you'll learn why that is the name. So, for example, when sine theta is x, then if we want to find the theta, that's what we're going to use arcsin of x. We can either write it as a -1, looking like the exponent, or we can use the arc, so it's arcsin. That would be arcsin x. When cosine theta is x, then theta is cosine inverse, or arccosine x. When tangent theta is x, then of course theta would be inverse tangent of x, or arctangent x. So let's have a look on how that works. But I do need to pull up a calculator, so here it is. For the first one, we're going to have sine inverse 0.5. So finally, on your calculator, you have been just seeing these sine, cosine, tangent on the top. Well, when we were trying to find secant, cosecant, and cotangent, we can't use these. But finally today we can. That is the inverse of sine. This is the inverse of cosine, and that is the inverse of tangent. So the first one, inverse of 0.5, we do want to make sure the mode is actually in degree, okay? And then we are going to clear that. Oh, I forgot to actually click enter. We're going to need to change it to degree, then clear. Okay, inverse sine, so that means you're going to need to click second, then sine 0.5. And that is going to be 30 degrees. Because we're actually getting angles, so don't forget to write the degree symbol. Okay, next, tangent, inverse tangent of 1, so second tangent of 1. And that would be 45 degrees. And next, inverse cosine of 0.086. So inverse cosine of 0.86 will be 31 degrees. Because we're rounding to the nearest whole number, so 31 degrees. Okay, next, second sine 0.75. That would be 48.59, so round to the whole number, 49 degrees. Hey, more. Now, you see the notation looks a little bit different, so this time you just need to write that extra step. So tangent d equals 6, that means if we want to actually calculate d, is going to be inverse tangent of 6. Okay, and let's actually calculate that. So inverse tangent of 6. That would be 80.53. We're still rounding to the whole number, so it's 81 degrees. Next, sine c. So in order to find c, see, we're trying to get into a function. That's why we need the inverse. So it's going to be inverse sine of 0.2250. Let's might as well just write out everything. So b is inverse cosine of 0.1045. And a is inverse tangent of 1.2799. Okay, so let's get to it. We have inverse sine of 0.2250, and that is 13 degrees. Okay, let's continue to calculate all of them. Then we have inverse cosine of 1045. That would be 84 degrees. They're all 0.00, so it's just 84 degrees. And next is inverse tangent of 1.2799. Enter. That is 51.99, so it's going to be 52 degrees. Now let's actually write them down. So we have a 13 degree, we have an 84 degree, and then we have a 52 degree. Continue. We have more. Now we have 2 layers. So first, we need to find the inverse of cosine 0.5. In fact, you can actually type everything into your calculator together. So tangent, and inside there is going to be our inverse cosine of 0.5. Let's close both layers of parentheses, this one for the 0.5 and this one for the whole inverse cosine. Press enter. That is 1.73. And now you might be like, wait, so does that mean I still need a degree symbol? Not here, because now the inside is going to give us the degree. So if you are curious, let's find out. Inverse cosine of 0.5. That is 60 degrees. So it's like after you find out inverse cosine 0.5 is 60 degrees, then you're just calculating tangent of 60 degrees. And that is 1.73. So for these, let's actually round to the 2 decimal places. Okay, next, same thing. Sine, and then inverse tangent of 1.5. That is going to be 0.83. Okay, next, cosine of inverse sine of 0.72. And that one is 0.69. Okay, next is tangent inverse sine of 0.05. That is going to be 0.05. Okay, there we go. So that's up to L. Now we're going to up things a notch. We're going to be finding cosecant, secant, and cotangent. And here's the issue with all of these functions, secant, cosecant, and cotangent. They're not on our calculators. So we have to first convert them into sine, cosine, and tangent. So finding cosecant A equals 1.4663 is the same as finding out what is cosecant is corresponding with sine. So we're going to find out what is sine A first, and then afterwards, we're going to find out A. So sine A is actually going to be 1 over 1.4663 because they are reciprocal of each other. So we can just use the value, use 1 divided. Okay, and then that means our A is actually going to be inverse sine of 1 over 1.4663. To make sure everything is precise, we're going to type the whole thing into our calculator. So inverse sine of 1 divided by 1.4663. Okay, and that is going to be 42.99, so 43 degrees. So next, let's write things out again. Secant, in order to find secant, we need cosine. So cosine B has to be 1 over 1.0353. That means B is inverse cosine of that 1 over 1.0353. Let's type in your calculator. So inverse cosine of 1 divided by 1.0353. Okay, 15.00, so 15 degrees. Next, cotangent is related to tangent, so tangent C is going to be 1 over 0.6494. And now in order to find C, it's going to be inverse tangent of 1 over 0.6494. So let's type it in. Inverse tangent of 1 divided by 0.6494. And that is going to be 57.00, so 57 degrees. Now more practice. Same thing. Let's actually write things out first. That one is related to cosine. So, things is actually a little bit different. So this time is secant, inverse secant is 2. But the issue is we don't actually know, have secant, cosecant, or cotangent on the calculator. So we still have to use cosine to be able to help us. So this basically means secant an angle is 2, which means cosine of that angle is going to be 1/2. And then we're going to need to use inverse cosine of 1/2 to be able to find out what exactly is the angle. So inverse cosine of 1/2. And that is going to be 60 degrees. Right, so a little bit faster is if you already see this, and this basically means the angle is that, you can already use the number and then use the opposite, the reciprocal trig function to actually find it already. So cotangent, if you want, you can always write it out. So cotangent A is 0.2679. That means tangent A is 1 over that. And now in order to find the A is going to be inverse tangent of 1 over 0.267. So compared to the other, the M through O, we just have to write that one extra step so we can see it a bit clearer. So let's see. Inverse tangent of 1 divided by 0.2679. That is going to be 75 degrees. Last one. This means cosecant of an angle is 1.4142. Okay, that means sine A is going to be 1 over 1.4142. Okay, so I can actually find angle A being inverse sine of 1 over 1.4142. Let's find it. Inverse sine 1 divided by 1.4142. And that is 45 degrees. So M through R is a bit tricky. Make sure you understand how these works. Moving on. Example 2. This time, we are going to use that to help us find the angle. So find the measure of the angle and round to the nearest 10th place. We're given all three sides, but this is the angle we're trying to find. Based on that angle, 3 is the opposite, 4 is the adjacent, and 5 is the hypotenuse. So we can actually write out all three of the most basic trig ratios. Sine theta is going to be 3/5. Cosine theta is going to be 4/5. And tangent theta is going to be 3/4. Now, you can use any one of these to find out what exactly is theta. So let's say you use sine, then theta is going to be inverse sine of 3/5. If you're going to use cosine, it's going to be inverse cosine of 4/5. If you use tangent, it's going to be inverse tangent of 3/4. They should all give you the same value. So in fact, you can just find one trig ratio and then use the inverse to find out what the angle is. So let's find it. Inverse sine of 3 over 5. And that is 36.86, 10th place, with 36.9. Don't forget the degree symbol. Okay, example 3. Now you're only given two sides. Based on the theta being here, 7 is the opposite, 11 is the adjacent. The trig ratio that involves opposite and adjacent is tangent. So tangent theta is 7 over 11. Now in order to find theta, it's going to be inverse tangent of 7 over 11. Inverse tangent of 7 over 11. That is going to be 32.47, so 32.5 degrees. That's example 3. Moving on, example 4. Theta being here, we have the adjacent side and hypotenuse. The trig ratio that involves adjacent side and hypotenuse is cosine. So let's go with cosine theta equals 14.5 over 16, which makes theta the inverse cosine or arc cosine of 14.5 over 16. Let's type in the calculator. Inverse cosine of 14.5 divided by 16. And that is going to be 25.0 degrees. Now example 5. I just realized you might have not seen example 3, so let's quickly have a look at it again. So there you go. That's for example 3, since it involves opposite and adjacent, so that's why we use tangent. Okay, for example 5, this is the angle, and you can use any pair. So let's say you want to use tangent, then 4 is the opposite, 3 is the adjacent. That means tangent theta is 4 over 3. That makes theta inverse tangent of 4/3. So inverse tangent of 4 divided by 3. That is going to be 53.13, so 53.1 degrees. And that's example 5. In the next lesson, we're going to use the inverse trig function and the normal trig function to solve some triangles. Thank you.